Question, we're asked to name some acids. Acids are covalent compounds because they contain only nonmetals. However, in some certain situations, they do behave like ionic compounds. So they're a special classification of compounds called acids. I'm not going to say too much more about them now, but you will study them in greater detail. You'll work with them in the lab, and you'll become much more familiar with them as you study chemistry. Now I want to talk a little bit about the rules, some basic rules of naming acids. These rules are not working 100% of the time. Said another way, there are exceptions to these rules, but I do want to quickly go through the basic rules of naming acids. First, if you have a monoatomic ion, like iodide here, so you have HI, so I minus would be a monoatomic ion, you use the prefix hydro. So this is called hydroiodic acid. So hydroiodic is one word, acid. Hydroiodic acid. If you have HCl, again monoatomic ion chloride, even though these aren't technically ionic compounds because they're covalent, because they contain only nonmetals, again, they do sometimes behave like sort of like ionic compounds. This would be hydrochloric acid. So hydrochloric acid. So hydro is for monoatomic ions. There is an exception to this. The most common one is hydrocyanic acid, which is Cn-, which is a polyatomic ion. So sometimes we use hydro for polyatomic ions, but generally it's for monoatomic ions. So these are a couple of examples. When it comes to Oxy Anions, which are all the rest of the cases here, there are also some rules. First of all, if it ends in "ite," it becomes an OUS and then acid. We change the suffix to OUS and then add the word acid if it ends in ite, ITE. If it ends in ate, we use the suffix ic, acid. So we use IC, acid. Like here we used chloric acid, but we added hydro in the front. So let me give you an example with these compounds here. Here we have hypochlorite. So if we had HClO, which is from the hypochlorite Oxy Anion, since it ends in ite, this becomes hypochlorous acid. Hypochlorous acid. We leave the hypo, and since it ends in ite, we add us acid, OUS acid. If it's just chlorite, so if we had HClO2 minus, oh, no minus, no more minus. If we had HClO2, then this would be just chlorous acid. Because in this case, we don't have the hypo anymore, so just chlorous acid. So the ite becomes us acid. In this case, we have chlorate. So if we had HClO3, this would be called chloric acid. So when we have 8, we use ic acid. And if we had HClO4, we again have an 8, but we have the per prefix here. This would be perchloric acid. So with Oxy Anions, there are generally specific rules for naming them. So let's look up here. Here we have H2CO3. Well, if we look here, carbonate is CO3, so this is the most common Oxy Anion of carbon. So since this is carbonate, this is just simply carbonic acid. This acid actually forms when you dissolve carbon dioxide in water, such as in a bottle of soda or seltzer water. Here we have HNO2. Well, NO3 is nitrate. Therefore, NO2 is nitrite. So if this is nitrite, the polyatomic ion, for ites we use us acid. So this is nitrous acid. Then, finally, we have HiO3. If we look at iodine, IO3 minus, iodate is the most common oxy anion. So this is iodic acid. We use ic acid because this is iodate. So with the oxy anions, we can convert their names to different acids.